Hi, this is Shreyank Siddharth and welcome to another interesting video where we will learn about coroutines in Kotlin. Well, this video is going to be a little bit long video, but trust me, once you watch this video, you will have a solid understanding of what are coroutines and how to use them in code. So I will make you understand this topic in the simplest way possible, in the layman's language. So firstly, what are coroutines and what is it used for? Well, to understand what are coroutines, you would need to first understand how exactly your application works when the user launches your application. So when the user launches the application, a default thread is created, and this thread is known as the main thread. Now this main thread is the life of the application. Let us represent the main thread with the help of this blue arrow. So what is the purpose of having the main thread? Well, the purpose of having the main thread is to perform some operations. And these operations are very small and lightweight operations, such as the UI interactions, click of the button, mathematical operations, or lightweight logical operations. So basically on the main thread, we perform small operations. Now, what about the long and heavy operations, such as that requires the use of internet, or upload or download of a file from the server, loading and displaying an image from the server, or running some heavy database queries? Well, if you run these heavy operations on the same main thread, then in that case, your main thread will be blocked. And when your main thread gets blocked, then your application will freeze. In simple words, your application will get hanged. And in case if your main thread remains blocked for a longer time, such as 5 seconds or something, then eventually your application will shut down with a crash message. And I am sure while using any application, you must have experienced such things where your phone becomes slow and your application crashes, right? So, running such heavy operations on the main thread is indeed a bad idea. To counter this situation, we have a solution. Instead of using the main thread, we can create a worker thread or the background thread. And on this worker thread, which is also known as the background thread, we can run heavy operations, such as we can create a thread to perform some network operations. We can create another background thread to download or upload a file. Similarly, we can launch more background threads to load images or to perform some heavy database operations. So in general, you always create a new thread to perform some heavy operations, and that would make your main thread available for other small operations. So this is how actually your application works, right? Now, these background threads sounds like a solution, but there is a limit of how many background threads you can create at a time in your application, because creating threads is very expensive. And if you create more and more threads, then there would be a time when your device will run out of memory. And eventually, once again, your application will shut down with a crash message. Hence, creating so many background threads is also not a good solution. It's a bad idea. So what is the next solution? Well, here comes coroutines into the picture and to the rescue. So when you use coroutines, then you don't have to create so many threads for each operation. Instead, you can just have one background thread, and on this background thread, you can launch coroutines, such as launch a coroutine to perform file upload operation, launch another coroutine on the same background thread to perform some network operations. Similarly, launch one more coroutine to download a file. Similarly, we can have more coroutines to perform other operations like this. In short, with the memory consumption of one background thread, you can perform so many heavy operations. How cool is that? So this is what coroutine does. Nice and simple. So I hope now you got an idea of where does a coroutine fits in your application. Fine. So now, moving ahead, how do we define a coroutine? Well, you can think of coroutine as lightweight threads. Similar to threads, coroutines can run in parallel, wait for each other to finish, and even multiple coroutines can communicate with each other. But remember, coroutines are not threads. So please note this. This is very important. Their functionality might look similar, but they are totally different. They are not same. And the biggest difference of a coroutine when compared to a thread is that coroutines are very cheap. They are almost free. We can create millions of coroutines at a time, and we don't have to worry about the memory consumption. Your application will run as smooth as you can imagine. So that's not possible in case of threads, right? You cannot create thousands of threads at a time. So for modern applications, coroutines are indeed the modern solution. Don't you think this is awesome? Well, of course it is. That's why coroutines are trending today, and that's why you are here to learn about it. So now, how to use coroutines? Well, to use coroutines, we would need a Kotlin project, right? So let's create a new project in IntelliJ IDE. So let's create a new project, and from left, select Gradle. At the top, it will show you the project SDK, which is default JDK available in your system. From here, select Kotlin JVM. Make sure only this is selected. Fine. Then click on Next. Provide the project name, Kotlin Coroutines. Then do nothing, just click on Finish. While creating a new project, make sure you have active internet connection. Otherwise, it won't work. And creating a new project might take a little time. So please have patience. So once your project is created, you will get your build.gradle file right in front of you. If you don't see it here, then from your project, navigate to build.gradle file. And within this file, within dependencies, just add this statement. Well, this statement will integrate Kotlin coroutines in your project. And since coroutine library is published to the JCentral repository, so within repositories, just add this statement, like this. And then here at the top, you will find this icon. Load Gradle changes. Let's click on it. This will integrate coroutines and apply the changes to your project. So once you are done, navigate to the main folder, navigate to Kotlin, and within this folder, let's create a new Kotlin file. Let's name it Kotlin Coroutines itself. Select File, Create. Let's minimize the Project Explorer, and here let's create a main function. Now, this main function actually operates on the main thread, which we just saw in our slide. And if you write some code within this main function, such as a few print statements, like this, then these two print statements will also execute in the main thread, because they are being called from the scope of main function, which is running on the main thread, right? To prove my point, I am going to print the thread name, like this. Let's run our program. So here we go, we are indeed operating on the main thread. Perfect. Now, let us create a background thread in place of this statement. By using thread lambda expression, just select the first one. So this thread function is going to create a background thread for us, which is also known as a worker thread. And within this thread, let us perform something. Let's add a print statement first. And also, we will verify on which thread this code will be executed. And after this print statement, let us pretend to do some work. So this will do some work for approximately 1000 milliseconds, which is 1 second. Well, in real projects, you would need to replace this statement by some real task, right? So don't use this thread.sleep statement in the real projects. Instead, you can write some code for upload or download of a file, right? This is just a dummy fake work. And right after this, let us print fake work finished, like this. So I hope this code makes sense to you now. Let's run the program. So here is the output. So here our main program started in the main thread and ended in the main thread, which you can see in the output, right? And the code that belonged to the thread executed in some other thread, which is actually the background thread. Fine. So how exactly our program was executed? Well, firstly, from the output, you can observe that these two code were executed independent of each other. They both started and ended in their own way. So this statement, which is the print statement over here, first produces this output. And then in sequence, when this thread lambda expression was executed, then it launches a new thread in the background to do these works. So this background thread did not block the code of the main thread, which also means that now these two threads are running in parallel. Hence, immediately after this statement was executed, the code within the main thread resumes. So this statement will not wait for this background thread to finish its work, because they both are running in parallel, that is, concurrently. So immediately after the main program starts, you get main program ends in the output console. And now, since the background thread was running in parallel, therefore the code here within the thread once starts to execute produces output accordingly, such as fake work starts and finish. Perfect. So what I want to say is that the code in the background thread did not block the code of the main thread. They ran in parallel, that is, in concurrent manner. Quite simple, isn't it? And also, if you run the program again, then you will find that there was a gap of 1 second between these two statements. It is due to our fake work going on at this line of code that lasts for 1 second. Fine. Now moving on, here I want you to note one more thing. Even after the last statement in the main function was executed, then also the application waited for our background thread to execute and complete. And only after these three statements were executed, our application ended. For which you can find a statement here, process finished with exit code 0, which means our application ended. So just note that in case of threads, the application waits for all the background threads to complete. So only after the code within the thread were executed completely, then only our application ended. Right? So please note this, what happens in case of thread. I will come back to this point shortly when we will discuss coroutines. Now moving on, let us replace this thread by a coroutine. So I will use global scope in camel case and select this one, kotlinx.coroutines dot launch function, this one. So once you do it, you will find these two imports. Even you can trim it down to like this using a star at the end and remove this import of thread. Great. So this launch function, what it does, it basically creates a background coroutine that runs on a background thread. and we can check on which background thread the coroutine is operating using this function. Great. And here we are again pretending to do some fake work, and after the work completes, we print fake work finished along with the thread name. So let's run our application. So here our main program started and ended, and our application also finished with exit code 0. But there are no signs of the output which belongs to this code over here. So what's wrong in our program, and why our coroutine code were not printed in the output console? Well, just now I showed you that in case of thread, if you use thread here, then the main function is going to wait for the background thread to finish their work, right? But in case of a coroutine, things are a bit different. When a coroutine is launched, the application by default do not know it has to wait for the coroutine to end its work. So this is another difference between while using a thread and while using a coroutine. Now the question arises, how can we make our main function to wait for our coroutine to get its work done? Well, for this we need to manually make our application wait for the coroutine to finish its work. So right here you can add thread.sleep and use 2000 milliseconds, which is actually 2 seconds. If you run the application now, you will find that our program right now worked perfectly fine this time. And also for these two print statements, you will find we are not operating on the main thread. The name of the thread is something which belongs to the background, that is other than the main thread. So now, how this statement has made our program to work? Well, this statement, what it basically blocks the current main thread and wait for the coroutine to finish. So that is why here I have used 2 seconds in the parameter, which is greater than this 1 second over here. Fine. So this delay of 2 seconds will wait for this coroutine to get its job done. And then right after waiting 2 seconds, the main program ends and our application ends, right? So yes, this is how we create a coroutine, do some dummy work, and make our main function to wait for the dummy work to finish. Now here you might ask a practical question. Suppose if our real job is to upload a file to the server, for which you need to write code in place of this statement over here, then in that case, practically it would be impossible to know how much time it will take for the file to get uploaded. In short, we won't know what time we need to fill here within the thread.sleep function so that we can wait for the coroutine to finish, right? Which means practically this statement is useless for the real projects. So in the real projects, what exactly we need to write in place of this statement so that we can wait for the coroutine to get its job done? Well, for the answer, you need to wait a little bit. Right now my intention was to just show you how to write your first program using coroutine. So wait a little bit, follow my coroutine videos, and you will definitely get your answer at right time. That's my promise. Perfect. So let's get a quick summary of what we saw just now. So we create a thread using this lambda expression in Kotlin, and we delayed the thread or pretended that we are doing some job by using this thread.sleep function. And then we saw how to create a coroutine which is attached to a thread by using this syntax. But we used the same thread.sleep function within our coroutine as well. Now this thread.sleep basically blocks the entire thread. So if some other coroutine are operating within the same thread as this coroutine is operating, then it will basically block that other coroutine as well, which is not good, right? And it basically violates the principle of using coroutine. So what is the solution to this? So instead of this thread.sleep, you can use the delay function, which again takes time in milliseconds. So this delay, when executed, does not block the thread on which it is operating. Let me elaborate it and show you how delay function is more efficient than thread.sleep function. So here, when this code is executed, a thread is created. But when thread.sleep function is executed, then for 1 second, your thread will be completely blocked. Meaning, for this time frame, your thread won't be able to do other tasks. It gets busy, right? Now, let us come to our coroutine code. So when this code is executed, it creates a coroutine that is attached to a thread. For clarity, let's name the coroutine as C1. And of course, there could be other coroutines that are operating on the same thread. I guess no doubt till now, because we can have multiple coroutines on the same background thread. Now, when this statement delay 1000 is executed, then it basically suspends the coroutine for 1 second. But it does not block the thread at all, which means the execution of other coroutines are not at all affected. They keep operating in the normal manner. So I hope this clearly shows you the differences between the delay function and thread.sleep function. So here in our program, let us replace this function by delay function. Now moving on, I want to talk a little bit more about this delay function. How does it work? So let us start from the beginning. So when we launch a coroutine, then let us assume our coroutine starts on thread named T1. Let us assume that. So the next statement which will be executed will of course execute on thread T1, right? But when this delay function is executed, then it basically suspends the coroutine or pauses the coroutine. And in that case, the thread T1 becomes free, meaning the thread T1 is firstly not blocked and it can associate with other coroutines to perform some other task which we saw in the slides, right? But after delaying for 1 second, when this print statement executes, then what do you think? On which thread this statement will be executed? Well, here is a little twist. It is not necessary that this statement will be executed in the same thread T1. It could be thread T1 or it could be some other thread, maybe T2 or T3. So let us run the program. So here you can see that it is just a coincidence that this fake work finished statement was executed in the same thread as it was executed for the previous statement in the same coroutine, right? But it doesn't mean that this thread will always be same for both these statements. It can definitely change if we run program in future. Now, this changing of the thread concept is not only applicable for the code written after the delay function. So on the left here you will find a symbol. It says suspend function call. Well, what is a suspend function? I will come to this shortly. But in place of delay, if we have some other suspend function as well, then also this changing of thread is applicable in that case as well. So please note this. Now right after our coroutine within the main function, we have again thread.sleep. Let us replace it again by a delay function. And here the compiler is not happy. Let's see what's the error. It says you cannot call the suspending function from outside a coroutine. So what does that mean? For that, let's see the definition of this delay function in the documentation. Well, the delay function is of the type of suspend. This is a special modifier found in Kotlin. So this creates a new question for us, such as what is a suspend modifier and what are suspending functions? Well, you can define suspending function as a function with a suspend modifier is basically known as suspending function. and the suspending functions are only allowed to be called from inside a coroutine or from another suspending function. In short, you cannot call the suspending function from outside a coroutine. So this is the reason why the compiler was complaining us. So please remember these 3 points. These are very basic but very important things to remember while dealing with coroutines. So now we know that this delay function is a suspending function, which means you cannot call delay from outside a coroutine. So how can we call a delay function over here? Well, the solution is to wrap the delay function within run blocking lambda expression. Like this. Run the program again. So here the output remains the same. So this run blocking function, what it does, it basically creates a new coroutine, but this time the coroutine blocks the current thread, which is the main thread in our case. So when you launch a coroutine using run blocking function, then it basically blocks the thread in which it is operating. So in our case, run blocking is going to block the main thread. And then calling the delay function will wait for our previous coroutine to finish its task. Right? So what we were able to achieve using thread.sleep function, we are achieving that now by using these 2 lines of code. But again, this is still not exactly the right way to wait for other coroutine to finish the work. Well, what is the right way to wait for other coroutine to finish? We will check it little later, not right now. For now, just focus on the concept that I am teaching, because we have just started with the topic of coroutines. Now moving on, also note that these 2 functions creates a new coroutine, right, that runs in parallel. But these 2 functions are completely different. This launch function creates a coroutine that does not block the main thread or the thread in which it is operating. But this run blocking function creates a coroutine that blocks the main thread. So right now just remember this small difference between them. We will discuss more about them later. Now moving on, you can present the entire code in a little different way. Suppose if you wrap this entire main function within run blocking lambda expression like this and remove this run blocking from here and run the program again, then in that case the output remains the same. Fine, so what changes I have just done? If you analyze the code in sequence, then this main function starts to execute in the main thread. Then using run blocking, we launch a new coroutine that blocks the main thread, meaning this coroutine runs on the main thread. Then this print statement will run on the main thread, because this print statement lies within the scope of run blocking method that is running on the main thread. So please note that. But when this launch function is executed, it creates a child coroutine, but in a background thread, meaning this entire code starts executing parallelly in concurrent manner in the background. Let us assume the thread is T1. Now, this delay function is actually present within the scope of run blocking function. So this code is going to execute on the main thread. Fine. And then finally, this print statement will again execute on the main thread. So I hope things are now clear. Why wrapping the delay function using the run blocking is exactly similar to that of using run blocking in the entire code, like this. Now, while dealing with coroutines, it is very important for you to keep track of the threads that are being used. So that is why right from the beginning of this video, I am emphasizing on the thread being used at each and every line of code. And trust me, if you are clear with the basics, then this topic of coroutine will become very easy for you. Fine. Now, you can further write this entire same code in more optimized way. you can make this main function as a function expression and use run blocking here. And what you can do is you can just remove run blocking from here and remove this curly bracket. Great. So this entire main function will create a new coroutine. Well, it is the way we write code in Kotlin, but don't worry, the output remains the same. Perfect. Now moving on, let's come back to the topic of suspending function. We actually got deviated from this topic to explore run blocking. So you can also create your own suspending functions as well. For that, all you have to do is you can use the suspend modifier, give function name and define parameters like you usually do. Then you can write your own code further. For example, I will call a delay function and provide the time which I am receiving here as parameter. Like this. And then you can call this suspend function from within the coroutine, like from here and also here. It is going to execute my suspend function and pass 2000 millisecond as a parameter, which will further call the delay function. So I guess no doubt till now, and the output of course remains the same. Fine. You can run the program yourself and verify the result. If you are feeling jumbled at this point of time, then let us summarize and get a big picture of what we have covered so far in this video. At this point of time, we now know what are coroutines and how they are different from threads. We then learned how to set up a Kotlin project and add coroutine dependency by using Gradle. Then we saw what are suspending functions and how to create such functions on our own. Then we also saw two ways to create coroutines. First by using launch function and another by using run blocking function. We also explored the basic differences between them. I hope you remember that. And above all, we always explored on which thread your coroutine is operating. Well, remember, if you are able to keep track of threads while using coroutine, then you can very easily write complex code using coroutine in your application. And in case if you have any confusion regarding threads while using coroutine, then you must watch this video once again. There is no harm in that. And if you are curious to know what is the exact way to wait for the coroutine to finish, or if you want to know more about run blocking function and its right usage, then you must watch my next video in this coroutine series. So I hope you enjoyed this video. This is Shreyans Siddharth signing off. Thanks for watching and see you in the next video.